Alarm 8, 9, or A on the Alpha I servo amplifier is a high current alarm. Alarm SV600 is generated by the CNC when it detects that an amplifier has a high current alarm. In parentheses, the alarm will indicate the axis that the amplifier controls. If it is a multiple axis drive, you will get an alarm for each axis. Unless you know exactly which amplifiers drive which axes, the best thing to do is access the electronics cabinet with power on, safely please, and look at the status displays of the units while the alarm is occurring. You're looking for the unit that is displaying either an 8, 9, or A. After you lock out the machine, pull out and plug back in the board that makes up the faceplate of the amplifier, the one with all the cables plugging into it. Oh, I didn't mention locking the machine out yet? Let me fix that. The servo amplifiers are in the electrical cabinet, and opening the cabinet with power applied potentially exposes you to danger. In order to accurately troubleshoot the exact cause of this alarm, you will need to have power applied to the equipment. Don't attempt to perform anything discussed in this presentation if you are not both fully qualified to do so and have the equipment owner's permission to do so. Once you are done troubleshooting, and before performing any maintenance, follow all plant safety and lockout procedures. These procedures should include releasing all energies related to the maintenance procedure performed. Okay, why are we looking for 3 different indications? Alarm 8, 9, and A are all the same problem. The difference is which amplifier axis the alarm exists on. 8 is for the first axis, which is labeled L on the amplifier. 9 is for the second axis, which is labeled M on the amplifier. And A is for the third axis, labeled N. So if your amplifier only controls 2 axes, like the one shown here, it should definitely never pop up an A. Now that you know which amplifier is alarming out, let's figure out what the trouble is. With this alarm, you basically have a short to ground. The short is causing too much current to flow through the power module inside the amplifier and will eventually break it, if it hasn't already. There is a gotcha to this alarm. On most machines, the amplifiers turn on when you turn on the main breaker, and then you press the on button to turn on the CNC and bring the servo system online. If you turn on the breaker, leave the CNC turned off, and the servo amplifier has this alarm right away, it's almost fixed. Unplug the feedback connector to the amplifier axis that the alarm is on and try it again. If the alarm goes away, you have a problem with the feedback cable or the pulse coder it goes back to. If the alarm is still there with the cable unplugged, the amplifier is bad. In a little bit, I'll discuss checking the motor and power cable. You should do that too, but you definitely need a new amp. Now, if the alarm only comes up once the CNC is turned on, keep looking for the problem. The next thing to do is disconnect the motor power leads from the amplifier. They are plugged into the bottom. If you are removing the motor power for a vertical axis, make sure you physically prop up that axis because we're about to make it fall out of the sky. With the motor power leads disconnected, turn on the CNC and release any emergency stop condition. With the e-stop released, servo motor brakes will release too, so hopefully you didn't skip the prop up the axis step. If the drive displays the high current alarm again, replace it. You know it's bad. The motor needs to be checked as well to see if it's what broke the amp. No alarm is a decent sign, but doesn't give the amp a clean bill of health yet. Now we'll check the Intelligent Power Module, or IPM, in the amplifier. This is what delivers the current to the motor. You will make 6 checks. With the DC link completely discharged, measure resistance with a standard multimeter from the top bus bar connection to each of the motor power pins on the bottom of the amplifier. You should read hundreds of K ohms up to wide open. You may find using a lead with a clip makes it slightly easier. You're going to check between the top bus bar and all 3 pins that connect to the motor power. If the 3 readings are not balanced, let's say within 10% of each other, the IPM is bad, which basically means the amp is bad. You might see 2 readings with high resistance and 1 with a short. That's a bad IPM. Maybe it's not a short, but it's just much lower resistance. That's a bad IPM. Next, move your lead from the top bus bar connection to the bottom one and check resistance of the 3 motor power pins again. You're still looking for high resistance, but it will be in the tens of K ohm range instead of hundreds. You are still looking for the 3 readings to basically match each other. Any more than 10% variance should be considered bad. Remember, the 3 readings made on the top bus bar will be different than the 3 made on the bottom. No shorts and balance is the key. Out of the 6 checks you made, don't be surprised for only 1 to be bad. That's usually how the IPM fails. You might be tempted to only replace the IPM and the amplifier. If the IPM is bad, it's a near certainty that it damaged the logic board as well. When you replace those 2 parts, you're basically replacing the amplifier, but you're not getting a warranty for your efforts. Replace the whole amplifier, and the amplifier will be covered by our parts warranty, as long as you also check the motor. To check the motor, you need to put your standard multimeter away and use an insulation tester, better known as a megohm meter or megger. The megger checks resistance while pumping voltage into the wire and will detect a high resistance short. Your multimeter will tell you that a dead shorted motor is good. Connect the megger to machine ground and check the reading on the pins of the cable you disconnected from the amplifier. One of the 4 pins is ground. That one will read a dead short. The other 3 should read above 100 megohms. Anything less is a short circuit. If you measure a short, disconnect the cable from the motor and check the cable again with both ends disconnected. Now everything should be above 100 megs. If you still measure a short, you need a new cable. All too often, when the motor shorts, it takes the cable out with it. Ignore it and risk repeating this process in a few months. Now check the motor directly by connecting the megger's ground lead to the shell of the motor's plug. Check all 4 pins again. 1 will be a dead short, the ground pin. 2 shorts means you need a new motor. If you notice that almost everything said a moment ago contradicts the chart shown here, you passed! The chart applies when you have a fully functioning machine, get bored, and decide to go meg some motors. If you have been led to get your megger out due to an alarm, 100 megohms is your go, no-go point. Ordinarily, swapping parts around is part of the troubleshooting process to prove a particular part out as bad. At no time during this presentation was swapping parts suggested, only replacing them. This alarm is dangerous, and if you swap parts around, you stand a chance of creating extra problems. Please don't move parts around to troubleshoot this one. Finally, this is a really rare situation, but occasionally you may experience that you can't conclusively determine whether you have a short in the amplifier, cable, or motor, yet you still get high current alarms. Replace the servo amplifier if you find yourself in that situation. We're here to answer your questions when you have them. Call 888-326-8287, press 2 for CNC, and then press 2 for technical support. To reach the part sales department, press 2 for CNC, then 1 and 1 again. Thanks for watching.